In this video, we're going to fine-tune 5.4 using a free GPU in Google Colab. This video will be broken down into 7 different sections. We're going to talk about how to install the packages, downloading the 5.4 model, preparing the dataset, training, setting different training arguments, training and saving the model, doing various inferencing, and also VLLM support, how to actually save the model so you can actually deploy it using your own VLLM server. Now, let's get into it. By the way, I make similar videos like these on LLMs, machine learning, and other data science tools, so please feel free to subscribe. Now, first things first, actually installing the different packages. The only 2 packages that you guys will need to install is the Unsloth for the Colab and the Xformer library. Now we've done that over here, as you can see over here. Now what we have to do is load our model. Now before we do that, make sure you guys have the HF token in your environment enabled. This HF token can be found in Hugging Face dashboard, so make sure you guys get that. So first things first, let's import Unsloth and then set some arguments, or I should say configurations, for the max sequence length, D-type, and load in 4-bit. In this case, it will be true. We are going to be quantizing the model using Unsloth, which will make it much more easier on the GPU while we are fine-tuning it. And then we can use the fast language model from Unsloth and load our 5.4 model from the Microsoft repository. We pass in the max sequence length, which we defined over here, D-type, and load in 4-bit. And then we press run. Now this will essentially download our 5.4 model into our environment and load it to the GPU. Okay, now we have loaded our model. Took around a few minutes, but here we go, loading all the different model shards and also the tokenizer. Once that is loaded, we will have to add our LoRa adapters. This is what is going to allow us to fine-tune specific parameters of the model, making it much faster to fine-tune. So we use the fast language model.get model and we pass in these configurations. These configurations are the number of parameters that we're going to use, or number of modules we're going to use to actually fine-tune, define gradient checkpointing for Unsloth, put a random state, use rs LoRa to false, and loftq config to false or none. After done that, let's close the bracket, run that. Now we're ready to actually fine-tune our model. Now before we do that, we actually have to fix our dataset. To do that, we want our dataset to look like this. We have a user tag, end tag for the user input, the assistant tags, and then the user again. Now we have an open assistant conversation that is available on Hugging Face that looks like this. We're going to format this really messy looking data to be able to feed into our model for fine-tuning. Now to do that, what we have to do is we have to get the Unsloth chat template. It's very nice that Unsloth actually provides this. We're going to get the tokenizer or reinitialize the tokenizer with this template, and we're going to make a function called formatting prompt function, which will essentially take our examples from the dataset that we'll download from here and format it using different examples available over here. So now what we have to do is from the transformers dataset package, load the dataset where we take the training split, and then we map the function that we defined over here. So let's run that. Shouldn't take too long. If we inspect it, we have around 9,000 rows with conversation and text. Now, because this is a demonstration on how to fine-tune a 5.4 model, I will not use the entire 9,000 samples, but I'm going to use a very small subset. So let's take maybe 500. Here we took that. This is how the dataset looks like. We can print the text, and this is the formatted version. This is before, and this is after, with the different tags, as you can see over here. Now, we have to do one more thing, is to apply an Unsloth template, which we can do like this, where we pass in the EOS tokens, we run that, and now we finally get to train our model. So let's do that. So first things first, let's download the packages we need to fine-tune our model. So we have TRL, transformers, and Unsloth, and SFT trainer, which is the supervised fine-tuning trainer over here. This is actually a provider from the Hugging Face. So technically, you don't need to use Unsloth if you don't want to, but although I recommend it personally. So we can still use the SFT trainer from Transformers and load the model as you would normally using Hugging Face, and you should be able to fine-tune it in the exact same way with minimal effort. So we define the trainer over here. Now here, we loaded the model, the tokenizer, the dataset that we can use to fine-tune the model, the dataset text field, where is the fine-tuned text that it can find, the max sequence length as we defined earlier, dataset numproc 2, and packing equals to false. And now we're going to pass in our training arguments. These are the arguments that will be used to fine-tune the model and change the different parameters of the neurons. Now this is how you can pass in different arguments over here. Now, when you're finally have your data set and you fine-tune the model, you may want to fiddle around with different learning rate, warm-up steps, max steps to see what maximizes your final results when it comes to accuracy and performance and whatnot. So these are the different types of parameters you may want to play with and experiment with. And by the way, if you guys want to experiment with this, it is highly advisable from my end to actually use weights and biases. I'm not sponsored by them, but they really help you track the differences in performance of the model with different parameters. So highly recommend. But in this case, we're not going to report it to weights and biases because I can't be bothered to set it up right now, but I recommend it nevertheless. Again, I'm not sponsored by them. So we're going to end this, parentheses over here, and then load this information. So this is the current memory stat. Before we train the model, we have a maximum of 14 gigabytes, and we have 10 gigabytes of memory reserved, which is quite amazing considering you can fine-tune a 5.4 model, although it's a very small model and a very potent model, but you can do it completely for free. No initial investment required. So let's train it. So here we can see the trainer has quick started the fine-tuning procedure. Now all you have to do is just wait. Okay, so now the training is finally done. Let's see how long it actually took to actually fine-tune this nice model. So in total, it took around 12 gigabytes of GPU memory. We had around 14 gigabytes, as you guys know, and took around 22 minutes to train this 500 samples of model, which is quite a long time. Now, how do we actually make inference on that? So let's do that. So there's two ways to make inferences on this. One is to use the normal inferencing that we typically do with Hugging Face. I'm going to show that right now. And we also can use Text Streamer, which is a much more nicer way or more continuous way to generate tokens. So for the first one, the boring one, let's load our model first. So simply we load the model like this, and then we define the message that we want to use to make inferences on. So continue the few sequence, 111, 2, 3, 5, 8, and so forth. And then we're gonna pass in the input data through the tokenizer and to the model. So finally, we'll do output equals model.generate, put the input IDs, max neo tokens, use cache, and then we decode the output. So let's run that. And here we have the final output as one string over here. Now, as you can see, we had to wait until we got the final series of tokens. Now this is a single way, a batch way to generate a bunch of tokens from the model. But what if you want to continuously see what tokens are being generated? And to do that, you can use a text streamer, which is relatively new. Well, not new anymore, but it was many months ago. So as you can see, it's continuously generating these tokens second by second, which is a more dynamic way of doing things. Now, after that exciting stuff, how can we actually save the model? Now, I've had a lot of different emails, people saying like, hey, I can't really deploy my model that I've fine-tuned using Onslaught. What is the best way to do that? So if you guys are going to use VLLM, which is most likely most people typically do not save it to GGUF format. Please save it to 16-bit. So here is one way of doing it. Another way is by defining the merge 16-bit over here, and you save that model either to your local machine or Hugging Face Hub. And if you do, please pass in the token over here. You can merge, you can save it to 16-bit, 4 floating bit, or LoRa, or just the LoRa adapters. So here's one way to do it. This is recommended if you guys are using VLLMs to deploy and serve your model. If you guys are using Llama CPP or want to use GGUF, then you can use these different settings over here to save your model. Alright guys, that's a quick video on how to fine-tune 5.4. I hope you found this video insightful. If you guys did, please feel free to subscribe. I make similar videos like these. Also, don't forget to book a call with me if you guys want consultation or want my help to build any AI applications. Alright guys, hope to see you in my next video. Have a nice day.